Welcome to Lab 2. In Lab 2, you will learn some basic C or C++, Hello World, and if else. In the beginning, you need to download the software Dev C++, install it in your laptop. I have the installation file already. Now double click to this. Okay. I agree. Next. Install. After finish installing, you will see the shortcut on the laptop. Here. Okay, finish and run it. English. Next. Okay, so this is the environment of the Dev C++. You want to create a new file, click to this, new, and short file. Here, this is where you can put the code. So we will make the window a bit smaller. Okay, so you can see both the lecture and the code at the same time. We already created a new file. This is where you can put the code here. And now copy and paste the following code into the window. So you can copy it, paste to the Dev C++, and then click to this button for compile and run to here. So we need to have the location for it. So I see Lab2 save, and you can see it show up the word hello world here. Press any key to continue, so it will disappear. Okay, next, let's change the text that you like. So in hello world we can change anything. We can say this is my Lab2 of elect 6035, something like that. And then when you click compile again, it will show up the text that we put into the code. So this is very simple. So now let's analyze the code. We have something green here called include stdio.h. At the moment we just know that we need to include the library stdio.h to use the command printf here. We have the int man open bracket, and we have the curly bracket open here and close here. Printf, we have the quotation mark and semicolon. Semicolon should be at the end. So next, so this is the template for programming C code. Usually we need to include more library if you have more complicated C code. At the moment in this lecture, you only use stdio.h library, that's it, okay. And we have the int man here, open bracket, close bracket. We have curly bracket here, and some command. We need to end with a semicolon. So now we can add command to the code. So command is just to make the reader to understand what you are doing, and it doesn't affect to your code. For example, if I want to make the code here, I can use this. Let's say this is the command to output the text, something like that. I also can use the command anywhere. I can put the command, the comment here. Or if I want to put comment up more than one line, I can make this. And then I can put anything. I can put anything here more than more than one line, something like that, or you can type anything you like. Any text inside this just be the comment, and there's nothing affect to your code. And usually in the beginning we should state some description of the code. For example, I say this code is to output a text, something like that. And the command bring f here is to bring some text out to the compile window. So we just delete it and then try to do it. First we need to include open it stdio.h. We have int man, open, it will close it for you, open again, and you can use any command print f, open the quotation mark and text anything here, and then make sure that at the end of the command you need to use the semicolon. Okay, we compile it will output the text anything here. If you forget the semicolon and then you press compile and run, it will say we missed the semicolon here, so it will help you to navigate the error in some case that you forget anything. Okay, we move on. For this code here, the flowchart is just symbol star, output the text hello world and end. I let you to get used to the flowchart because in the future you will learn more complicated flowchart. The flowchart go with the code. It is a good habit for you in the future. Next, so we will learn the syntax of if. So if we have the if and we put the condition here, and if is correct, it do something, command if the condition is true, and if not, it will end. So the flowchart here is star, if condition, if the condition is correct, do the command, and if we know, we will move on to the next command. Okay, so let's see some example. This is write a code to compare a value a to 15. So we have the same structure, include stdio.h, int man here. We have int a here, a equal to 20, and semicolon here. And if a is larger than 15, we output the text a is larger than 15. And if not, there's nothing happen. So let's try to do this code. We have the default code here. Just say int a equal 20. We say if open bracket a larger than 15 and open the curly brackets, it will close automatically for you. We say print f quotation mark age is larger than 15. Don't forget to end with the semicolon, then compile, and this say a is larger than 15. So let's try with another value. If a is 10, so 10 is less than 15, so there's nothing happens. We compile, but there's no text here. So if we try 100, compile, we see 100 is larger than 15. So that's a simple text. What's int here? So int here is mean for integer number. So if I say int a, that means a an integer number. It will be 1, 2, 3, 4, 5, 6, 0 or -1 or -2, -3, something like that. Next. Okay, so now we move to if else. So we have the if condition. If the condition is true, we do something if body here. If it's not correct, it's not true, we do the else command, and we move next to below else. So for example, this is the code. We do again, we compare A to 15, but now we have the else. So if A is larger than 15, we bring out the text A is larger than 15, and if no, we can say else, open curly bracket, we say print quotation mark, A is less than or equal to 15. Don't forget the semicolon at the end, and then compile. So here in the code we have A equal to 100, so 100 is larger than 15, so its output A is larger than 15. If we change the value to 10 and compile again, it say A is less than or equal to 15. Okay, if I say A equal to 15, compile again, it say A is less than or equal to 15. Next, so now we move to the a bit more complicated of if, else, and else. So the syntax of it is if condition 1, do command 1, else if condition 2, do command 2, else if condition 3, command 3, and if everything is incorrect, it will do the command 4. So you can see the flow chart here. If condition 1, yes, it will do the command 1 and it will move out to the end. It's similar to condition 2, do command 2 and move out to the end. Condition 3, and if the condition 1, 2, 3 is not correct, it will do the command 4 and it will move out to the end. You can have more or less than 3 conditions. Okay, so let's see the example. Here the same, but if we say if A equal to 15, say A is equal to 15. Else if open bracket, else if we say print f, else if I forgot the condition, else if condition A is larger than 15, print f, A is larger than 15, semicolon, and if else, we say A is less than 15. Okay, so compile. So A is equal to 15. Let's change, for example, 1 and compile again. We'll say A is less than 15. Okay, so this is the comparison operator. You need to use 2 of the equal sign. So here this is comparison operator. If you say something equal to something, you need to use 2 equal sign. If you say something is not equal to something, use this, less than this, larger than this, less than or equal. This is the greater or equal. So be careful with this. Okay, we have the integer. We have int here. So int for integer. The integer number, it can be negative to positive, and this is the maximum value of the integer can be. This is the minimum value of the integer can be here. Very big value. And some example, you can say the integer number can be some negative number like minus 63, or positive number is 1990. And we can say the syntax for the code here is a integer, and we have the variable, for example x here, or you can say a, b, or c, or d, anything equal to a value. Or if you don't have any value, you just say integer and the variable y, z, or something like that, and we can assign the value of the variable later. We also have the data type of byte. So a byte is only 8-bit number, so it will have a short range from 0 to 255. If you use any value that's less than 255, you can use byte, because when you use byte, you will use less material in the compiler or in the microcontroller, and your code will run faster. And they also have the unsigned int. So unsigned int, this means unsigned integer. So it starts from 0 to this value, very big value here. And it's only for positive number. You can say 2021 or 6035, something like that, very big. And the syntax for it is say unsigned int, and any variable c or d and equal to something, some value, or just the variable without the value. And there's one data type that you need to understand is the float. So float is the floating point number. It can be both positive and negative, and it have the decimal value here. For example, it's not an integer. It can be 19.6 or 21.8, something like that. So if you want to define a value of pi, you have to use the float. So the float here, you can say pi equal to 314. Okay, next. So we have some example of the data type. This is the code. So I can delete this. And then we can define the value of ABC. So we say A is an integer, and if I want to have one more value, I can use comma B, comma C, and at the end I have to use semicolon, something like that. And I can define the value A equal to 20, B equal to 5, C, you can say equal to A plus B. And I output the text, so bring F, I can say the sum of A and B is C, something like that. And let's run it. So you can see that the output of the result is the text. The sum of A and B is C. So we don't have the value of A, B, and C. So if you want to put the value of A, B, C, you change A to a percent %B, B to percent %D, and C to percent %D, and comma, and the first percent %D is A. So say A. The next is B, and the final percent %D here is C. So C. So by doing this, it will show up the value of A into this percent %D here, the value of B into the second percent %D, and the value of C into the third percent %D. So now compile and run again. It will show up the text. The sum of 20 and 5 is 25. So A is 20, B is 5, and C is the sum of A and B is 25. I can use the minus. If A minus B, I see A minus B is C. So something like that, and I say 20 minus 5 is 15. Yeah. So this is how you define number. So you percent %D to output the value of variable. So first percent %D is for A, the second percent %D for B, and the third percent %D is C. So I can change the value. For example, if I say C is equal to B minus A, So I say b minus a equal to c. So I change the first percent d is b, the second percent d is a, and the third percent d is c. So compile again and say 5 minus 20 is minus 15. Okay, so that's how it works. And this is the code that we use. We also can define AB and put the value into it in the beginning. So there's many ways to define a variable. First, we define A, B, C are integer. We can say A integer, B integer, C integer, something like that. Or we can combine it as before, A, comma B, comma C, semicolon. Or we can put the value directly into the defined code here, A equal to 20 here, comma B equal to 5 here, and C we don't have the value, so just put it's blank. So we can do the code something like this. It's much nicer. Compile. Okay. Now we will use the scanf to input the value. Here, the value here we have the A equal to 20, B equal to 5. You have to input manually in the beginning. So if we don't want to input manually in the beginning, we can use the command scanf. So how to use this? For example, if I only have a variable, and I want to bring out the value of a. For example, I say a equals 20, bring the value of a. Okay. Let's say the value of a is. Compile, and we say the value of a is 20. Or if I change the value of a is equal to 10, let's bring out the value of a is 10. So now if I want to input this manually, I can say scanf, and the syntax of it is %d, comma, and a. So and now I can put it into the compile window. I need to input the value of a here, for example 9, and it output the value of a is 9. Okay, so when you use the scanf, you can put the value into this window. Now, so I want to make it clear, so I make a text printf. Enter the value of a here. Okay. And semicolon, and then compile it again. Okay, it's wrong because I'm missing a T here. Bring F here. Compile again, so enter value of a here. And then we need to enter the value of a. So for example 7, enter, and then it moves to the next command, bring the value. The value of a is 7. Okay. So you can have one more line of confirming the value. If we come back to the example of if, we say write code to compare value a to 15. We can say if a is larger than 15, print So A is larger than 15, and we want to change the value of A into the real value, so I can say %d comma A, and the semicolon at the end, and then press compile and run. You can see enter the value of A here. We say 6. We say the value of A is 6, and nothing happened because 6 is less than 15. So again, I say enter value of A here, say 60, enter, and we say the value of A is 60, and 60 is larger than 15. You can see here there's two text in the same line, so I cannot see it very clearly, so I want to enter to a new line. So how to do it? So I can put backslash and end. This is like a enter, to enter a new line. So compile again, say 60, so say the value of A is 60, and then it moves to the next line. 60 is larger than 15. Okay, so use this to output to the next line. Use %d to output the value of the variable, and scanf to input the value. Okay, let's move to the example 2. Example 2, we use if else. So if A is larger than 15, output A is larger than 15, else if not, printf, say A is less than or equal to 15. And we want to change the value of A to the real value, so %d and A. Compile. Oh, I forgot the semicolon. Okay, compile again. Yes, enter value here, about 3. So say the value of A is 3, and 3 is less than or equal to 15. Okay. So this is the end of the if-else code. So remember to do your assignment, and thank you very much.